Hi, in this video we'll continue studying the inverse function of the other trigonometric functions. We will go very fast, just list the main idea and what is the restrictions we need to do on the trig function to be able to define the inverse of that trig function. Okay, so we already did sine. Let's start with cosine. I will recall that what we had in the case of sine here happens again, meaning that the function sine itself is not one-to-one. To make it one-to-one, we restrict domain on the interval negative pi over 2 and pi over 2, such that the function on that interval is one-to-one, and then we can define the inverse. This story, we need to repeat this story for all the other trig functions. And basically, we have to fix where is that interval that we have to restrict our trig function to be able to get a one-to-one function. So in the case of cosine, the graph is something like this, and then continues going like that. Well, all the trig functions are periodic, so if we go back, and that's why they are not one-to-one. So the restriction we need to do is that we'll take 0 to pi, and you will see, okay, if I delete that piece, the remaining is actually a one-to-one function. So what we made is that domain restriction is 0 to pi. And well, the graph of the function, then you can see that the graph of the inverse function is going to be something like this. So it will start from here, go there, and then come out like that. The domain will be again a -1 and -1, and the range will be from 0 to pi. So let me just write down these facts. The notation we choose is cosine inverse or R cosine. Cosine inverse of y is x if and only if the cosine of x is equal to y. What we have to make sure that it is also in that interval. Domain of cosine inverse is -1, 1. The range is 0 to pi. And well, this definition, the way it is defined, will give us this property, the inverse property or cancellation property, that cosine of cosine inverse of x is always x. But when you do cosine inverse of cosine, you have to be careful. This is only true if and only if the x is between 0 and pi. So this is inverse function property or cancellation, some people say. Inverse property. That's what you need, and then similar stories can happen for the other one. Let me do one more with the graph. That's tan function, tangent function tan. What is this? The graph of this function is it has vertical asymptotes at pi over 2 and negative pi over 2, and every multiple of pi over 2 plus pi over 2. So you multiply that by a constant and then add pi over 2. That will give you another. Yeah, so those are the vertical asymptotes, and what will happen is that the graph is something like this. Well, never intersects, sorry. That is my drawing, not the tan function. And then goes down like this, and then repeats itself like that, and repeats itself like this. Well, to be able to get one-to-one function, what we do, we restrict ourselves to this interval on this branch. So basically the from negative pi over 2 to pi over 2. Remember that the cosine tan at negative pi over 2 and pi over 2 is not defined, so the intervals needs to be open interval. Well, as a result of that, we have the graph of this inverse function. The inverse function will have something like this. It's funny, nice, something like that. The vertical asymptote in this case will turn into horizontal asymptotes, and we have the definition. Yes, the definition says, well, tan inverse or arctan of x is equal to y. X is equal to y if and only if y, the tan of y, okay, tan of y is equal to x, and y needs to be in this interval negative pi over 2 and pi over 2. What else? The domain of tan inverse, as you can see from the graph, is the whole real line. The range, however, is the open interval negative pi over 2 and pi over 2. While the inverse property would be tan of tan inverse is identity, or will give you back whatever you put in. But tan inverse of tan, you have to be careful, only true if x is a number between x is between pi over 2 and negative pi over 2. Well, we can extend this list, the list to the secant. I will just write the definition for this one. Secant inverse. Well, let me just write the definition, secant. Then for cosecant and for cotan. What is the definition? Everything bodes well. The way they're defined are exactly same as the other ones, with one thing that, well, what is the interval you're taking here for this? For example, for secant, there are possibilities. Yes, you can take more than one, but the one that we are going to fix as our convention is this 0 pi over 2 and from pi to 3 pi over 2. This way it will get both positive and negative values. For secant, cosecant, for cosecant, the definition goes the same way. So x is cosecant of y. But the interval is interesting. Again, 0 to pi over 2 closed, union pi to 3 pi over 2. Well, there are good reasons to choose these intervals, but we won't go into that in this course. And well, for cotan inverse of x, this is cotan y is equal to x when y is between 0 and pi. So you have to know these guys. And by the way, these intervals are going to be the domain of the inverse function. So you have to know these ones and use them when you need. Yeah, so then basically you have the list, and well, you have to be able to work with the values and do examples.